changing my environmental footprint through the installation of solar panels, a presentation of mathematical problems. This presentation will discuss how the installation of solar panels on my family's home will reduce or completely eradicate my family's use of non-renewable electricity supplied by power companies. By reducing our need for non-renewable electricity, my family will be able to reduce the footprint we leave on the Earth's environment. To begin with, we must first discover my family's electricity usage. To do this, we will look at my family's power bills for a year. Below is the energy consumption for my household for the previous 12 months. This is displayed in quarterly interval. As can be seen, each quarterly billing period has a slight difference in the number of days due to the uneven number of days in each year. So to get an accurate, even energy usage figure for each quarter, we must divide each quarter's bill by the number of days in that quarter to give us our daily electricity usage. In the first quarter there is 92 days, so we must divide 1607.38 kilowatts an hour by 92 days, which provides us with a daily usage of 17.47 kilowatts an hour per day. In the second quarter there is 91 days, so we must divide 1896.47 kilowatts an hour by 91 days, which provides us with a daily usage of 20.84 kilowatts an hour per day. In the third quarter there is 92 days, so we must divide 1688.2 kilowatts an hour by 92 days, which provides us with a daily usage of 18.35 kilowatts an hour per day. In the fourth quarter there are 90 days, so we must divide 1815.6 kilowatts an hour by 90 days. This provides us with a daily usage of 20.17 kilowatts an hour per day. According to infinityenergy.com.au, a 6 kilowatt solar panel system can produce differing kilowatts an hour of energy per day depending on the amount of optimum sunlight they receive. According to Australian radiation figures, June produces the lowest amount of sunlight per day, which in turn will produce the lowest amount of optimal sunlight for the solar panels. To figure out the lowest amount of energy a 6 kilowatt solar system will provide my household, we must convert kilowatts into kilowatts an hour. To do this, we will use the equation kilowatts an hour equals kilowatts times time. According to Australia radiation figures, my home city of Melbourne receives an average of 3.75 hours of optimal sunlight a day throughout the month of June. 6 kilowatts times 3.75 hours equals 22.5 kilowatts an hour per day. With my household's highest average daily usage of 20.84 kilowatts an hour, we can see that 6 kilowatt solar system is the right system for my household, providing room to move if our electricity consumption increases. The next step in the process of reducing my household's environmental footprint is to ensure my home's roof is suitable for a 6 kilowatt solar system. Infinite Energy's 6 kilowatt solar system comprises of 24 1.6 metre by 1 metre panels. To ensure the solar panels will fit on my roof, we must first work out the area of my roof. To figure out the total area of my roof, we will times length by width squared. As seen in the image, my roof is 19 metres in length and 4.6 metres wide. 19 metres times 4.6 metres equals 87.4 metres squared. Unfortunately, because of the roof's trapezoid shape, you cannot fit solar panels all over, so you must calculate the rectangular area of my roof. As we can see, the rectangular area of my roof is 13 metres in length and 3.5 metres wide. When we work out the area of this roof, we can see 13 metres by 3.5 metres equals 45.5 metres squared. If we mount the solar panels atop each other as shown in the diagram, we could place 2 rows of 12 panels running horizontally across the roof. The area of this would be 12 metres in length times 3.2 metres wide, which equals 38.4 metres squared. This would sufficiently fit all 24 panels atop of my roof, and also allow my family to completely eradicate our need for non-renewable electricity supplied by power companies. Also, the solar panels would be giving 1.66 kilowatts an hour of solar power back to my energy company per day. We get this number by taking away my family's maximum energy usage of 20.49 kilowatts an hour per day from the 22.5 kilowatts an hour a 6 kilowatt solar system would provide my household in the month of June. Looking at the amount of renewable power solar panels would give back to my energy company in the month of June, we are able to see that further investigation may lead to a greater decrease in my family's environmental footprint. According to Australian radiation figures, the month of January provides the largest amount of optimal sunlight for solar panels in Melbourne, with an average of 9.42 hours of sunlight per day hitting the solar system in the month of January. If we convert these hours of sunlight into kilowatts an hour, using the previously mentioned formula of kilowatts an hour equals kilowatts times time, we can see that 6 kilowatts times 9.42 hours equals 56.52 kilowatts an hour per day. If we take away my family's highest daily electricity consumption of 20.49 kilowatts an hour per day from the 56.52 kilowatts an hour per day the solar system is producing in the month of January, we can see the solar system is providing my electricity company with 36.03 kilowatts an hour of renewable electricity per day. Today I have shown unequivocally that the installation of a 6 kilowatt solar panel system would dramatically reduce my family's environmental footprint by eradicating our need for non-renewable electricity, while also supplying my energy company with excess renewable solar power.